for today's session. We'll start with the introduction of DNS. Then we'll have a view on the different security challenges, different types of attacks related to DNS. We'll look at both sides of DNS from an infrastructure point of view and from a client's point of view. Then we'll talk about different detection or protection mechanisms or the best practices today, the common ones rather. And then followed by the question and answers. But again, at any point of time, if you have any queries, you can talk me and we can address that. All right. Okay, let's move on. So I'm sure everybody is aware of DNS, which is domain name system, and how DNS works. Maybe people know at a high level, but basically DNS is what we need to for internet usage, for browsing internet. Well, it can be arguable. Some people might argue, saying that no, I can browse with IP addresses. Well, that is history now. Today, it's everything about name. Whether you have a small name or a big name or dynamically generated names, you need a name because it's not like humanly possible to remember so many IP addresses. So that's why easier way were developed, and the initial inventions, we can say, of web or www. And what we have is whenever, so if you see an example, just a basic example of how DNS works. So as a client, maybe from the browser, or whether it's from mobile or app or tablet or whatever it is, endpoint, tries to browse, suppose google.com. First thing it queries is its local DNS server. If it's a company, maybe a company's local DNS server, or maybe like ISP, maybe the internet service provider's DNS. And if it's a recursive query, so when it's a recursive query like google.com, which is this DNS is not authority of, so it forwards the query to the root DNS server. So when we say google.com, the root DNS server is like we have 9 root DNS servers, 13 depending, across the world. So it can go to any of the root DNS servers to find where the google.com resides. Basically, it will tell about .com, which is a TLD, top-level domain. And then basically the TLD server says, okay, google.com is, the authority for google.com is owned by Google, which is another DNS server. And it goes to finally to Google's DNS server, and Google finally responds to the client. So this is how at a high level DNS works for IP to, for name to IP resolution. Sometimes we also need the reverse, which is of different use cases. But for this session, let's consider when we're talking about DNS, which is name to IP resolution. Now, recently, there has been requirements of IPv4 and IPv6. So now, instead of like A records, which is IPv4 record, we have something called IPv6 record, which is called quad A record. The pattern is same, but the different, basically, the naming is almost similar. The resolution for A record, which is IPv4 record, it's giving an IPv4 IP address. And if we are trying to resolve a quad A record, which is giving an IPv6 IP address, that's the difference majorly. But at a high level, this is how DNS works. Any questions here? Any feedback or any comments? If not, we can move to the next slide. All right. So now we'll talk about, at a high level, different security challenges or issues with DNS. The first thing we'll look at is from an infrastructure point of view. So when we say infrastructure point of view, is our DNS server itself, where we are hosting our DNS services. So categorically, if you see, we see mostly volumetric attacks, which is DDoS, DOS, DNS amplification attacks. We do see DNS protocol misuse or the DNS service misuse, which is kind of protocol anomalies, NX domain. Again, NS domain can be volumetric. So I put at a high level 3 categories because this can be categorized in multiple categories, individual attacks. Some of the important ones today which we are seeing is, of course, DNS hijacking, DNS tunneling, DDoS, volumetric attacks, and protocol anomalies. Now let's take an example of few. So first one, DNS tunneling, which is one of my favorite ones. So DNS tunneling is used for multiple purposes of different types of attacks. One of the common ones is for misuse. Now, when we say misuse, so I'm not sure if you have seen this happening. A few years back when we used to travel, right? We would travel a lot. So in the hotel, you had to pay for internet, like $5 or $10 a day. So what people used to do that during that time, how to bypass or use internet without paying. So what people used to do, they used or they misused the DNS server because DNS was for free. You can query the DNS, but when you want to browse internet, then you have to pay. So what people came up with the idea, so there are free VPN services where you can just download the VPN client and connect using DNS tunneling. So what is happening is all your HTTP, HTTPS data is being tunneled using DNS packets via the DNS server. So to the service provider or to the company or to the organization, it looks as if only DNS data or DNS traffic is going out. But within the DNS packets, the data packets, different types of HTTP and HTTPS data was being tunneled through those DNS packets. Today also this is being used, but maybe less for bypassing for using free internet. Today it is more used for data exfiltration. So consider a situation where an organization is compromised. Some users in the organization is compromised, and the attacker has to exfiltrate data to outside the organization. Now, a common port is DNS, which is open in almost every organization. And I'm sure, I mean, today in this session, I can ask everyone, without DNS, there is no organization or no person who is running without DNS. DNS is must, right? So this is one of the very common channels of exfiltrating data. Now, people argue, okay, we have firewalls, we have IPS, which is blocking any kind of malicious attempt. But today, majority of the organizations, they're not able to detect DNS tunneling. Okay, that's because of multiple reasons, because the firewalls we have are, yes, they are network security devices, they do network security, but when it comes to DNS deep packet inspection or maybe understanding the DNS protocol, maybe at a high level, yes, but when it's tunnel, it's not able to detect tunnel inside unless we do some workarounds. By default, the signatures, they will not detect DNS tunneling. Well, there are some of the security solutions which are capable today, but majority of them are not able to detect DNS tunneling. And this is being misused, or this channel is being used by malicious hackers to do data exfiltration. Now, also in some organizations, they allow DNS outbound. So people, they try to use internet from their within the organization, bypassing their the HTTP or HTTPS or web security controls. Another one today, a very important one, is DNS hijacking. Sometimes we also see typo squatting, where both are similar, but very marginal difference. So we have like DNS squatting, where typo squatting, where people mistype domain names instead of maybe google.com, we type, instead of 2 O's, we may type 3 or 4 O's by mistake. So what happens is, if Google has not registered all those like mistyped domain names in their DNS server to redirect to their DNS server, maybe some malicious hackers, they have registered these typo domains and maybe redirecting the users' traffic to their own servers to capture information. This is very common. We have seen this happening with use cases for phishing. Also, sometimes what happens is, in phishing especially, you will receive a lot of phishing emails. Okay, there's some message in the chat. Let me have a look. Okay, nothing specific. So in phishing, so what happens is, we have similar domain names like a bank, suppose bank1.com. The phishing URL will be abc.bank1.com or abc.bank1.xyz.com. So for a user, they see the page when it's redirected to the malicious web page. They see the login page of the bank, but previously what people are, when you do training, anti-phishing trainings or security awareness trainings, we as an organization, we teach our users to, whenever they're browsing or they're visiting their internet banking websites, to look at the secure lock, right, on the website. So what hackers came out with the idea, they started to register the domains, the malicious domains, with valid certificates. So now, even if it's a phishing links, you're going to see the certificate valid. So for a user, it's becoming difficult to basically detect or malicious or non-malicious domain or legitimate domains. Other ways are other attack types: DNS cache poisoning, DNS protocol anomalies. So today, we see a lot of organizations are still using open source solutions for DNS servers because it's free, and there's nothing wrong. But the situation is, people tend to do misconfigurations, and basically once it is installed, they forget about it. They don't upgrade to the latest versions. They don't do security patches. So these issues or misconfigurations and protocol anomalies because of some bugs, maybe in the old version of bind DNS or whatever open source solution. These DNS servers are prone to attacks related to protocol anomalies, where people are trying to exploit the protocol, the anomalies in the protocol itself, trying to do cache poisoning if it's a recursive DNS, and if it's doing cache poisoning, they might try to redirect the users to different so legitimate domains, but the servers could be different when they're responding from the DNS. For hijacking also, we have seen this happening. Basically, users' PCs, the endpoints are being compromised, and their DNS resolution is being hijacked, and kind of which is leading to MITM attacks as well. NX domain in the DDoS is more related to volumetric attacks, where basically NX domain is whenever you're querying for a domain to DNS server, and the DNS server is not able to find any answer, like basically the domain doesn't exist, and it responds back to the client. So this NX domain thing is used by botnets mostly. So maybe there are 1 million botnets, the zombies, they query a particular DNS server for domains which doesn't exist. So the DNS server gets busy responding to these malicious queries, and the legitimate users are being affected. Similarly, we have seen in the recent times other types of amplification attacks also. coming to DNS servers. But a majority challenge is people, the organizations, they're not able to detect this kind of attacks coming to their DNS infrastructure. So lack of visibility. So if you have a bind DNS server, suppose an open source DNS server, you don't have a solution in the backend to monitor this on a daily basis, like how many queries we are receiving, what are the malicious types of domains being queried, whether there's some DNS channeling there. So whatever solution we use, whether it's open source or proprietary solution, commercial solution, it is very important to have a good visibility on the DNS traffic and their infrastructure, so that whenever there is any kind of abnormal behavior, it's quickly detected, and the response process or the incident response process can be taken into account. This is another interesting one, very recent in last 2-3 years. It has taken, it's very spreading a lot. So recently you have seen people talking about DNS used over HTTPS protocol and DNS over TLS. So historically, till today, we are using DNS protocol over UDP 53 port or TCP 53 port. But now, what researchers or some organizations who are more concerned about security and privacy, they came up with DNS over HTTPS and DNS over TLS. Now, with the existing setup of DNS over UDP port or TCP port 53, what happens is when you're browsing or you're doing DNS queries, your ISP or whoever is the authority for monitoring, they are doing deep packet inspection, or they're basically logging whatever sites you're browsing. And then out of that, they do analytics based on user behavior, and that can be used for marketing purpose or different types of analytics for user behavior and commercial purposes. So from a privacy perspective, if you want to keep your browsing data, or at least the DNS data, private, what you can do is you can use services like DOH or DOT. Today we have free services from Cloudflare, which is 1.1.1, Quad 9, 9.9.9.9, from Google DNS 8.8. There are a couple of others as well, but the most common one today is 1.1.1.1. So what happens is, suppose you have the app installed on your iPhone or Android, and there's an option. So let's go to the next page here. So there's an app. When you say start the VPN, so what it does is it creates a DNS tunnel from your phone to the Cloudflare DNS server, and whatever DNS queries you're making, it goes over HTTPS channel from your phone directly to Cloudflare and to internet wherever. So any monitoring solution in between is not able to see those data. Okay, that is over HTTPS. Now, HTTPS, because today almost all organizations allow HTTPS. Another way of doing or using this is DNS over TLS. Well, TLS, it's not over a standard port like HTTPS. You have to use a different port like TCP 853. So all organizations may not allow this port outbound, but for sure HTTPS is allowed. So you can try this app. Also, if you're using Firefox, there's an option to enable this DOH, DNS over HTTPS, and your Firefox browser, instead of using your local system DNS or your ISP DNS, it will directly bypass the DNS and connect to maybe Cloudflare DNS or whichever we set it up for. This is inbuilt in Firefox. You have to just change the configuration to use DNS over HTTPS. Very cool feature, and helps to keep your DNS queries private. Okay, now we will look at more from a client's perspective. So from a client's perspective, we talked about phishing, malicious domain, mistype, which is typo errors, malware, command and control, data exfiltration, and a very interesting one today, user and parental controls. So phishing and malicious domain, you have already seen that happening. People getting phishing links in their email, or today, nowadays it's getting into WhatsApp. People sending you short codes like bit.ly, short codes, short URLs, and basically at a first look you will not see that it's malicious, but once it redirects, maybe it is forwarding to a malicious domain. Mistype, we talked about that. Again, people mistyping the domain names or FQDN of a website, and it is redirecting to a malicious server. Similarly, we have seen a lot of recent malwares connecting to malware command and control servers, the backdoors, using DNS, because DNS is a protocol which is allowed in most of the organizations, and very common channel for sending command and control connections to the botnet servers. Data exfiltration, again, very common. Data from the organization's compromised PCs or clients are being sent to the malicious servers over DNS, again using DNS tunneling. User and parental controls, very new recent discussion using DNS, how we can control our users for or allowing or disallowing any particular website or category of websites. So as a home user, if you want to allow or block your, this feature is not available in all countries maybe today, but some of the countries they have started with, or some of the telecom operators, where you can have parental controls set up against your phone number or your internet subscription. So if you have given a phone subscription to your children, maybe a 10-year-old, another one is 18-year-old. So you might allow only specific category of websites to the 10-year-old and a specific category of, or rather more relaxed, to the 18-year-old. So which is based on your parental decisions, you can have parental controls of what browsing or what sites can your children can browse. This is a very interesting subject, again, not available in all countries. Similarly for user controls, though it's not very much used in enterprises, because enterprise already has today like web proxy servers where they are allowed based on categories. But organizations who don't have proxy and they want to restrict their users browsing malicious websites or category of websites can use this feature based on DNS, because whatever is the device, whether it's endpoint or a laptop or mobile, for browsing, they have to go through the DNS. And this is where DNS plays an important role of securing the endpoint. Some of the best practices in securing. So, okay, let me ask this. I'm sure everybody has heard about DNSSEC, right? Now, DNSSEC has been there for more than 10 years, but maybe 5% of organizations in the world have implemented DNSSEC. Now, why and why not is the question. So DNSSEC is a misconception across many people I have talked to, what people think once we enable DNSSEC, all our DNS communications is going to be secure and encrypted and all those things. That's not correct. So DNSSEC is basically a way we can authenticate the validity of a DNS query we are making, and we're making sure the answer is coming from a valid DNS server. Okay, it does not encrypt any DNS communication. Okay, so that is one way of securing DNS, but not what we are trying to achieve. So the first one we look at is the volumetric based attacks or exploits or protocol anomalies. Now, volumetric based attacks today, what we have is DDoS attacks, DDoS protection mechanisms, maybe Akamai or Impulse, Imperva, or whatever solution we use for DDoS or Radware or A10. They are not specific for DNS. If it's a slow slow DDoS, slowly, not too much volume of traffic, these solutions might not detect it. Well, Arbor has a module specifically for DNS, but others might not have. So we need to look at solutions which are purpose-built or which has a feature to detect DDoS and DOS or volumetric attacks based on DNS protocol itself. Second one is DNS tunneling. Still, a lot of organizations are facing this problem. They're not able to detect and block DNS tunneling. Well, some organizations may have workarounds to detect DNS tunneling using IPS or firewall for the sake, but once you start to block, it blocks legitimate traffic as well, because those solutions were not purpose-built to do deep packet inspection of DNS protocol and block specifically the DNS tunneling. So again, we need to, there are solutions like from Infoblox, from Palo Alto, where it is purpose-built to look at DNS traffic and detect DNS tunneling and blocking DNS tunneling. Running a latest version of the code, as we talked in the previous slides, people are installing a DNS server in maybe 2010 until 2019. It is running because DNS server, once it starts to work, it works for next 10 years without any problems, unless it is hacked or whatever. So a code which was installed 10 years back, it is still running, but it has a lot of inherent security problems from a configuration point of view, from a security point of view. Maybe there are a lot of bugs in the code. So those things, patches needs to be installed, the software needs to be upgraded, but people tend to forget DNS because for people, it's not as important as other components in their infrastructure. That's why it is missed always. But again, today we are seeing a lot of attacks based on DNS. So now it is people starting to look at DNS and securing the DNS infrastructure. Purpose-built security protection, we're talking about Infoblox, advanced DNS protection, Palo Alto, NGFW. There is something from Arbor, there's something from F5 as well, but not where you have to see which fits your organization's requirement. So all these are from an infrastructure point of view. From a client's perspective, if I have to block people browsing malicious domains or these parental controls, these are based on a solution or a feature in DNS protocol, which is called RPZ, Response Policy Zones. Different vendors call it in with different names, but from a Bind is basically the most famous DNS service. It is called RPZ, Response Policy Zones. So what happens is we can get feeds of malicious domains and malicious IP addresses from providers like Carbon Black, where endpoint security providers mostly, where they have databases, huge databases databases of malicious domain names. So what happens is we can inject these databases to the DNS server. So when the DNS client, tries to query any malicious domain and it matches this malicious domain databases, the DNS server can flag or redirect the users to a different website, maybe for training purposes. Also, this can be tracked and an incident process can be started based on whatever malicious domain the client is trying to browse. Also can be blocked and alerted as per the configuration. But the core feature with RPZ or response policy zones is to detect any client trying to visit a malicious domain. Again, you can integrate with your existing solutions. If you have subscription, many organizations today have subscriptions from different vendors like RSA or Carbon Black or Symantec or ThreadGrid, whatever. You can integrate your DNS solution or McAfee with different types of security solutions in your infrastructure. What else? This is the last topic, visibility, very, very important. So visibility is basically we want to see on a daily basis or a report or alert or dashboards in your security operations to see which are the top users querying DNS for outbound or outside queries, which are the countries there, because using solutions like SIM or whichever SIM solution you have, you can see where which countries these are hosted, these domain names, and where people are browsing, what type of domains is being browsed, what category of those domains are being browsed, whether you like in a specific browsing of a specific or querying of a specific malicious domain. So all these kinds of things can be reported and alerted from your visibility solution. Could be a SIM solution or maybe a paid one, a commercial one, or using open source solution like ELK or whatever you use, like Elastic Computing and stuff. So there are solutions today which helps to monitor DNS traffic, but yes, this is not being done by many organizations, and we are still not getting full visibility into our DNS traffic. So it's important or advised or recommended to have visibility on DNS traffic to detect any malicious use or exploit of your DNS infrastructure. That's all from my side. I think it's time for questions. If you have any specific questions or comments, I'll try to address. If I don't have answer, maybe I can respond back definitely. Please.
Yeah, hi Dhananjoy. This is Sapna.
Yes, sir.
Yeah, so as you talk about the monitoring and logging, so it's always a challenge to configure logging from DNS because the DNS logs are huge. So
yes,
when we enable the DNS logging, the logs has to be stored in the server itself.
Absolutely.
And then we can forward it to the SIM solution. So whenever we talk to the server administrators, they say that they cannot store logs like for more than 1 hour or 2 hours. So in that case, the log forwarding becomes the difficult part. So even though if we enable also logging, there is a huge performance issue. So how should we overcome such issues? Is there any solution available to have the monitoring and logging better, and that does not cause any issue on the performance?
Sure. Thank you, Sapna. That's a very valid question. It's being asked by almost every organization. It's their concern. Now, there are different ways of addressing this. So let's talk about the first question or first query from, suppose you have a Windows DNS server. Now, if I remember recent, like 2-3 years back, I was talking to a Windows administrator. At that point of time, it was Windows 2012 R2 server. So when we asked them to enable query logging for DNS, they were seeing like around 50 GB of logs per hour. So if you're talking of 50 GB per hour, maybe in a day, it's like more than 1 terabytes. So it is difficult to store these logs locally on the server and then forwarding to your SIM, because SIM, some of the SIM solutions, they're expensive. They count by the number of logs being received or events per second, or by the volume of data you receive on the SIM. So how do we address that situation? Now, what we can do is, if you're using a proprietary solution like or an open source solution like Linux bind server or a Windows DNS server, okay, we cannot store the logs on the server for long. So what we can do, we can enable remote syslog. So you have a syslog server centrally in your data center, and you can enable syslog forwarding. So whatever logs are generated on the server is forwarded to the external syslog server. Nothing is being stored. Or even if it's stored locally, it can rewrite every, suppose once it reaches a certain size, it can do rewrite of the data. But the data is not stored long for on the server locally. It can be forwarded to an external syslog server on the network. And then syslog server can process those. There are a lot of open source solutions like Cacti, ELK. You can use ELK. ELK is open source solution. You can use ELK, Elastic, and Logstash, and Kibana, where you can draw different types of dashboards and graphs, and also at the same time you can analyze the DNS data. And then after doing some certain filtering and stuff, you can forward it to your SIM solution for correlation of the data with your other logs in the organization. That is one way. Another way is, some administrators, they don't even want to enable DNS logging because it affects the performance of the server. Yes, definitely it does affect. So what we do is we use solutions like RSA Net Witness, where you can capture network traffic from the network itself. So when the DNS query is being made to the DNS server, from the network level, packets are being captured and analyzed by RSA Net Witness. So this is one of the solutions, or one of the ways you can do it. All right. So does that answer the question? Oh, well, there's more. There's Infoblox, which is the leading DNS solution provider. So in Infoblox, there is inbuilt reporting solution where it can give you different types of reports, dashboards, and alerting. Very, very stable solution. Also, if you are using Splunk, you can send it to Splunk, and Splunk also has inbuilt apps created for DNS. Okay, does that answer your question?
Yeah, thanks a lot. Thanks a lot for answering these questions, because we have been facing this issue from long time. So definitely the answer will help us now. Thank you.
Absolutely, yeah, thanks. Any other questions?
Ladies, any other question? If you have any issue, you can type on chat.
Hi, this is Salma. So no questions from my end. I just wanted to say thank you for the informative session, Sapna for organizing, and Danny for taking us through it. I know I'd made a request a little earlier in terms of the Sea Turtle campaign, and if you could provide more details, but I think it is pretty obvious, from the first to sixth and the seventh slide where you put in all the details and walked through that. So
sure. Sea Turtle has, so if you see, Sea Turtle is not, it was detected, it's been there from 2010, I believe, 9 or 10. So multiple instances were detected, and somewhere it was with malicious domain phishing, somewhere it was DNS hijacking, which is here. DNS hijacking, and some part was DNS cache poisoning and tunneling as well. So what was happening is some of the endpoints were sent phishing links. This is one of the use cases I'm saying. So in that phishing link, users were redirected to different malicious websites, and basically their username and or credentials were being taken away. Another use case was specifically for the DNS hijacking, and it relates to one of the service providers in Europe. What they claim is, so the client's PCs were being compromised, and suppose they were trying to access abc.com, because their DNS was being hijacked. So whatever they're querying, abc.com was being responded with the IP address of a malicious website. And that malicious website, the login page, looked exactly the same as that abc.com's website. Okay. Now the second thing which I mentioned was the Ssl certificate. So these attackers, what they did, they also bought the certificate with the same domain name of abc.com. So they went to a different certificate authority provider like Komodo or something, and they bought certificates from them with the same domain name as that valid website. So for the user, it was very difficult to detect that it was a malicious website, and their credentials was being compromised.
Right.
This.
So then I just want to understand, right? Given your expertise in the area of the DNS part, we know that awareness is one thing in terms of explaining to users, but what as information security officers, consultants, what are the other steps that people need to take in terms of managing these security challenges? We always talk about running assessments, having somebody come and do penetration tests and things like that.
Okay, so now that goes back to a situation where, first of all, you need to, when we are designing security, we look at different attack vectors. And for each attack vector, then we see what are the risks. Well, let's not get into risk. What are the technical, because I'm come from a technical background, so I always think about technical solutions. So what technical security controls we can put for all these attack vectors? Maybe one solution can detect or prevent multiple attack vectors. So when we are looking at solutions, we miss maybe some of the attack vectors are being missed, or maybe at that point of time it was not in priority. At a later point of time, when everybody forgot about that attack vector or that channel from where the attack was supposed to come or expected to come, everybody forgot about that attack vector, and that was where the attack came from and nobody noticed it. So if you take in terms of DNS, a very common one is you will see people still running Microsoft Windows DNS servers for public DNS, and it is open on the internet. And if you're still running Windows 2003 server and it's open to internet, it has so many vulnerabilities, that DNS process on Windows 2003. Well, the OS itself has a lot of vulnerabilities. So it is one of those situations where we have missed that attack vector, and that is being exploited to get into or for the damage what is going to happen. So what we recommend is, yes, it is not possible to put security controls into everything, but whatever solutions are external facing, at least we need to put security controls, and those security controls needs to be reviewed regularly. It's not that we put something today and we forget for next 10 years. It has to be reviewed regularly or periodic basis, so that if there are any new attack vectors introduced into the network, the infrastructure can be addressed.
Right. Thank you.
Okay.
Assalamu alaikum, Dani. This is Reem Shamir from Kuwait Oil Company.
Assalamu alaikum.
First, I would like to thank you for giving us the time and the efforts to prepare such a very rich and useful, informative presentation. And I would like also to thank our ladies. MashaAllah, today is a very great and huge audience. And I believe the topic you're presenting is very critical. That is very much related to the recent attacks has been raised within the adversaries and threat actors at the region. I would like to ask a very general question from a cybersecurity professional that is very much aware on our Middle East region and the cyber attacks. When you compare the cyber attacks types that is happening to the region, where do you place this DNS, let's say, in vulnerabilities and utilization and getting into the enterprises and the critical infrastructure? Or where do you see the most very trending attack, aside from phishing? Because everyone keeps saying phishing. Aside from phishing, what is the most impactful or very much trending you utilize in our Middle East environment? Thank you so much.
Thank you. Thank you for the question. It's a very valid question and a very important for our organizations today. So I'm working with a lot of governmental and banking organizations and telecom as well in the region. Now, what I see is like before, like 3-4 years back, when we were working a lot on SIM solutions and firewalls and IPS, that time nobody cared about DNS. Basically, DNS was like you can say helping service or assisting service to their mainstream services of web browsing or whatever. Now, during that time, everyone was ignoring this attack vector of DNS, because the first thing you do is if there is a malicious URL, if a client is compromised, the first thing it is sending is, it's no more sending over an IP, it is sending using DNS. If you remember, there was malware in the recent past where it was generating domain names on the fly. So every request, command and control request it was raising was using dynamically generated domain names. So this is a common practice now in the new malware types. So how do you block based on IP addresses? So if you have like thousands of IP addresses blocked on your network firewall or IPS, it's not possible. So we need something to look at DNS packets, to look inside the DNS packet rather, for anomalies, for any malicious pattern, for DNS tunneling, where the malwares are using DNS tunneling or to you send command and control commands or data exfiltration using DNS. So now I see people have started to look at DNS and they're implementing security solutions, because we work with Infoblox a lot. So I have seen almost every government organization, they have implemented this. There's something called Infoblox. I'm not saying a specific product, but this is one of the products we work with. That's I'm sharing my experience. Infoblox ADP, which is Advanced DNS Protection. This is where we are detecting DNS tunneling and any type of DNS related or volumetric based attacks coming to the DNS server itself. The second type of security is for the clients, which is in terms of response policy zones. Response policy zones, there is from Cisco as well, there's a solution. There is from Infoblox, which is called DNS Firewall. What they do is, they have given you a solution like You can install an agent on your laptop or your user's laptop. Even if the user is at home or outside your organization's network, this laptop or the endpoint is being protected for any malicious domains it's trying to browse. So it's not only about your organization within your network, it can be anywhere outside the network. The DNS can be, or DNS protocol can be used to provide security to the endpoints. And then the last one is, we talked about, where is that? Parental controls. This is another important feature in our lives today. And we are using DNS to protect or to do parental controls. So yes, DNS is one of the important topics of today's cybersecurity requirements.
Great, thank you, Danny. Thank you so much.
You're welcome. Any other questions or comments? I'm also sharing my email address in case in future, if you want to get any suggestion or any comments, any questions, you're welcome to email me.
Thanks, Danny.
Welcome.
So thanks a lot for your time today. And definitely we'll reach out to you in case of more queries. And as we understood from the presentation that DNS security is often overlooked. So we need to be focusing on securing DNS by doing monitoring, logging, creating use cases specific to DNS, as well as including the DNS in our assessments, because basically we focus on application security or network security, server security, but we missed this DNS security part. So I hope that this session is useful to everyone, and we are going to focus more on DNS security.
Thank you. And I would ask all the people in this session to have a look at this DNS over HTTPS because this is taking the center stage now. Everyone is talking about this, as this is one of the ways people are going to bypass your controls.
Sure, thanks.
Thanks, Danny.
Have a great day ahead.
Thank you.
Thank you. Bye-bye.
Bye-bye. Take care. Thank you. Thanks all.